Section 3-2 talks about relations and functions. So the definition of a relation is just simply a set of ordered pairs. And a set of ordered pairs would look like what we have here. This is just a set of ordered pairs. Not all relations are functions, but all functions are a relation. So again, not all relations are functions, but all functions are relations. And we'll talk about what a function is. So let's discuss how we actually show a representation of a relation. So one of them, as you can see here, is just a list of ordered pairs. So there's 4 ways. Another way is a table of values. So here's our table of values. You're told that this list of ordered pairs is track scoring. The place that somebody placed in their track event and the number of points that they earned. So we're just going to take each of these ordered pairs here and we're going to split them into their X and their Y values. So this is going to represent their X values and this is going to represent their Y values. Make my pen a little thicker. Let's do this, okay? And so the first ordered pair 1, 5 would go here. The next ordered pair 2, 3 would just go here, 3, 2, and then 4, 1. So a table of values is a way to show a relation, and a relation really is, in this case, it's a relationship between their place and how many points they received. So clearly if you receive first place, you're going to get more points, second place, fewer points, third place, even fewer, and fourth place, the least amount. We can also show these ordered pairs as a graph. So you have to decide on your graph, you've got a y-axis and an x-axis. You have to label those axes with what they are if you know it, and then give an appropriate scale. So on this x-axis should always go the dependent variable. So you need to ask yourself, and clearly you can see here that the place determine the number of points. The number of points did not determine what place that they earned. So they've already told you what the X value is, so it's really quite clear that this is going to be place and the Y values are going to be points. But the reason why the place is your X value is because it's independent. Nothing affects your place other than your performance, but what you place in will affect how many points you get. So the number of points is dependent upon the place. So I'm going to label this as place and this as points. And I'm going to partition my graph. The X values go from 1 to 4, so I need to go out to at least 4. And this is 0. And the Y values go up to 5. So I have to go up to at least 5. And then my table of values had a title, track scoring, so that same title is going to go on our graph, track scoring. And so then we're going to plot each ordered pair. So the ordered pair 1, 5 means I'm going to go from 0 over 1 and up 5 and plot a point. And then my second ordered pair is 2, 3. So I'm going to go over 2 and up 3, plot that point. My third ordered pair is 3, 2, plot the point. And my last ordered pair is 4, 1, plot the point. So this is just another way to show the relationship visually. The last form is called a mapping diagram, and it involves using ovals. So we've got one oval for the X's, one oval for the Y's. We're going to label this as X and this as Y. And we could even label them with place and points if you want to. And you should also title it track scoring. Now, the only difference between the table of values and this mapping are a couple things. Thing one, if your x values repeat, you are not going to repeat them here. So if you had 1, 1, 3, 4, you would just put 1, 3, 4. And if your y values repeat, same thing. You're not going to repeat y values here. You're just going to put one number. So in this case, we don't have any repeats, and I tend to like to put the numbers in order from smallest to largest. So my x's are going to be 1, 2, 3, and 4. My y's are currently not in order, so I'm going to put them in order from smallest to largest. 1, 2, 3, and 5. And then you're going to draw an arrow that represents this ordered pair. So in other words, 1 is going to map onto 5. So you're going to draw an arrow from 1 to 5. So it looks like this. And you have to have an arrow on the end of it. This is part of the mapping. And then we're going to map 2 onto 3. And then 3 onto 2. And then 4 onto 1. That's it. Those are the 4 ways that you can express a relation. So while we're at it, we're going to talk about what a function is. And we'll get to the official definition in a bit. So a function is essentially the easiest way to look at a relation and determine if it's a function would be to look at the x values. If the x values repeat, it is not a function. The y values can repeat. That's okay. But if the x values repeat, it's not considered a function. Now, on a graph, you can see the x values if they repeat quite easily. So on a graph, and I'm going to show this, we're going to use what's called the vertical line test. But in order to do this, I want to get a vertical line. Okay. And so I'm going to apply a vertical line. So here's my vertical line, it's my laser pointer. If I move this vertical line anywhere across the graph, does this vertical line touch the graph in more than one place? Nope, 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 nope. It only touches, my vertical line only touches the graph in one place at any time. No, there's no way I could put this vertical line unless I tilted it and slanted it this way for it to touch, and now it's no longer a vertical line. So as long as I have a vertical line, get back vertical, it only touches my graph once. So it passes what's called the vertical line test. And the purpose for that is if, let me get back to my regular pointer, if these x values repeated, like for instance, let's say that we had 2, 3, and 2, 2. So if you had 2, 2, you'd go to the right 2 and up 2, you'd have a point right here, which is vertical to that point. It would not pass the vertical line test, so it would not be a function. So this particular relation is a function because the x values do not repeat and it passes the vertical line test on the graph. Now let's talk about the definition for domain and range. Domain, this is your official definition. Domain is a set of first coordinates or x values of the ordered pairs. Really, this is the important part. Domain is x values. Same thing with range. This is the important part. Range are y values. And it's easy to remember because domain comes before range alphabetically and x comes before y alphabetically, so they match up. It's just another name for x and y values. And so if we use the relation above, this question is asking what is the domain of the track event in example 1. So the domain would be, and again, when you list the domain, essentially, it'd be easiest to find the domain from the mapping, right here, from the mapping right here, because we don't want repeated values in the domain and we don't want repeated values in the range. So typically I'll use the mapping here and here to write the domain and range. So our domain is 1, 2, 3, and 4, and the range is 1, 2, 3, and 5. In this question, it's asking you to find the domain and range, and we're also going to look at it and determine if it's a function. It says give the domain and range of the relation. So down here at the bottom, we are going to describe the domain and range both in words and also in symbols. What you'll notice about this particular graph is there are no ordered pairs here. So for instance, you don't see an ordered pair here at 1, 2, or at 2, 3, or at 3, 4. We can put them in there, but they're actually not there. And the reason for that is that those are not the only 3 points that are part of the domain and range. There could be a point right here, which would be 1.5, 2.5, and that's part of the domain and range of the relation. So before we actually describe those in words and in symbols, is this a function? So in order to determine if it's a function, I'm going to apply my vertical line test. So here's my vertical line. I'm going to run the vertical line through the graph. Does it touch the graph in more than one place? Nope. So if that's the case, then this is a function. It passes the vertical line test. All right, so let's describe the domain in words. So the domain are x values. And essentially our x values start here. Whoops, let me switch my pointer out to dot. Our x values go down the x-axis, starts here at 1. So here at 1, and it continues all the way here, right here, to 3. So in words, the domain it goes anywhere from, whoops, let me erase that. So it goes anywhere from 1 to 3 and including 1 and 3. So wouldn't that look like, let's just draw the symbols for the domain. Wouldn't that look like my x value would be less than or equal to 3, but greater than or equal to 1. So it's really a compound inequality. And so in words, I can say that the domain is less than, whoops, I don't know why I made a T, or equal to 3, and that's an important word, greater than or equal to 1. Your range, let's look at the range in first before we look at the words and the symbols. But our range is going to go to the y-axis. So our range here, the lowest part of our graph goes to a range of 2, and the highest part of our graph goes to 4. So our range is going from 2 to 4. So again, we can express that as a compound inequality. We're going to use y this time. Let's get my pen. So y is less than or equal to 4 and greater than or equal to 2. So in words, the range is less than or equal to 4 and greater than or equal to 2. Then on this one where it says your turn, before you turn off the video and do it yourself, I want you to add the following line to the mapping. I want you to add going from 8 to 3. I want you to add that right now because we've already talked about functions. And so at this point, I want you to turn off the video and then I want you to determine, well, before you turn off the video, determine if 1 is a function, yes or no, and why. Is 2 a function, yes or no, and why. And then find the domain and the range. Whether it's a function or not, it still has a domain and range. So turn off the video and then turn it back on when you're ready. Okay, so hopefully you've made your determinations. As I look at this mapping, first of all, it's missing the title or the labels X and Y. So I just want to point that out. And then notice here, it doesn't show X values repeating because you don't in a mapping, but what you do see right here are 2 arrows leaving the same X. So if I were to write this as a list of ordered pairs, one ordered pair would be 8, -1, and the other ordered pair would be 8, -3. Doesn't the x value repeat? So remember, if the x value repeats, it's not a function. So this is not a function. And the reason why is its x values repeat. But we still have a domain, and the domain is exactly what you see in the mappings. It's all the x values of 8, 9, 10, and 13. And the range are all the y values, -1, -3, and 5. And I want to point out also that even though there are 2 y values that repeat here, once I added that red line, it doesn't matter if the y values repeat. It only matters if those x values repeat. So we're going to circle that because that's the reason why it's not a function. Then let's look at number 2. Number 2 is a table of values. And in that table of values, if you're determining if it's a function, all you care about are the x values, the domain. Because the x values do not repeat, it is a function. So is a function. And the domain would be 1, 4, and 8. And the range would be the y values, 1 and 4. We're not going to repeat this second 1 here. So we're just going to put 1 and 4. And this is your last slide, and it talks about functions, which we've already done. I've already done a lot of talking about what a function is, but here is your exact definition of a function. A special type of a relation, because remember, all functions are relations, but not all relations are functions. So a function is a special type of relation that pairs each domain value with exactly one range value. So the important part of this is pairs each domain value with exactly one range value. And what that's saying is the x values do not repeat. That's really what that's saying. So then, for example, 3, you are to give the domain and range of each relation, then tell whether the relation is a function. So again, we've talked a lot about this. If I were you, I would stop the video, make your determinations, find your domain and range, tell why it is or is not a function, and then turn the video back on. Okay, so for example 3, field trip. We've got students as the x values, buses as the y values. So our domain is going to be 75. Oh, we could go in order from smallest to largest. I suppose that would be best. So let's go smallest was 68, then 75, then 125. Now there were no x values that repeated, so immediately you should make the conclusion that yes, it's a function. Why? No x values repeated. Or you could state the definition of the function up here, and you could say each domain value paired with exactly one range value. That would be giving you full credit. Now your range, we don't want to repeat anything in the range. The range has a repeated value of 2, so we're just going to put 1, 2 and 1, 3. All right, then your example number 4. So this is a mapping, and again, this mapping is missing the fact that, well, it has input-output. So I'm just going to put up here your inputs x, your outputs y. So your domain, as you can see, is 0, 1, 2, and 3. And because you've got 2 arrows right here coming from 0, that implies that there's a repeated x value. And so this is not a function. And the reason why, there is repeated x values, or there is more than one x value paired up with a y value. It doesn't matter that you've got 2 arrows here, and by the way, let me also point out, this is missing its arrows. It has to have arrows on the right side. Otherwise, it's not a proper mapping. The range would be, now that I've put my arrows in there, I'm assuming it's -2, 1, 2, and 4. That's it, folks.